Thank you for standing by, and welcome to the AMD Radeon Graphics Talks conference call. At this time, all participants are in a listen-only mode. There will be a presentation, followed by a question and answer session, at which time, if you wish to ask a question, you need to press star 1 on your telephone. I must advise you that this conference is being recorded today, Wednesday the 14th of December 2011. I would now like to hand the conference over to your speaker today, Ms. Chris Brown from AMD. Please continue.
Thank you, Joe. Good afternoon, everyone, and thank you for joining us today. Really appreciate your time. My name is Chris Brown from AMD PR. So our call today will focus on the AMD Radeon HD 7900 series graphics launch, codenamed Southern Islands. Please note that all call details provided today, as well as the NDA date details, are under embargo until 5:01 a.m. GMT, 6:01 a.m. CET, January the 9th, 2012. This absolutely includes discussion on forums and all other informal communications on the subject. Our presentation will last about an hour and a half with time for Q&A after. We're very pleased to have as our spokespeople today Devin Nekachuk, Product Manager, joining us from Toronto, Ab Nassef, Tech Marketing Manager, and Roger Cuero, Tech Marketing Manager as well, all joining us from our Canadian offices. So with that, let me hand you over to Devin.
Thanks, Chris. So hi, everyone. My name is Devin Nekachuk, and as Chris mentioned, I am a Product Manager here at the AMD Canada office. I focus on the high-end discrete products, and I think I have talked to many of you in person, but for those that don't know me, I've also worked on products such as the HD 6800 series, 6900 series, and 5900 series. So without further ado, I'll just go right into this presentation. As Chris mentioned, this is about the HD 7900 series graphics products. You might know them as the codename Southern Islands. And this is really an exciting product generation. We've been working on this for a long time, and there's a lot of cool stuff in this product generation, so it's very exciting to be able to talk about this product generation today. Before I get into the actual product details, I'd like to talk a little bit about the background on where the market is today. I mean, what we're seeing as a trend over the past few years is that graphics horsepower is just in more demand and more demand as years goes on. This is for a few reasons. One of them is just because the market itself for PC gaming is continuing to grow. So we're seeing that the PC gaming market alone is worth about $15 billion on hardware. So that's a lot of money being spent, and the graphics card is obviously a big portion of that PC gaming hardware market. The next one is that games are becoming more visually intensive. So I'm sure everyone on this call has seen or played themselves Battlefield 3. These are the types of games that really demand more graphics horsepower out of your PC. There's also a whole breadth of other games. You look at Deus Ex, you look at Anno 2070. There are a lot of games that are coming out that are really demanding a lot more from your PC hardware, and that's where the 7900 series really targets to deliver the next generation experience. People are also gaming at higher and higher resolutions. So the trend that we've seen over the past several years is that 1080p monitors are becoming the most common resolution. If you look at the Steam hardware survey, roughly 3 years ago, the most common resolution used by roughly 30% of gamers on the Steam hardware survey was 1280 by 1024. So that's pushing roughly 1.2 million pixels. Only 10 or 5% of gamers used a 1080p resolution monitor. Fast forward to today, and you'll notice that the Steam hardware survey shows that roughly 1/3 of gamers are using 1080p resolution monitors, and the portion of gamers using 1280 by 1024 monitors has dropped down to that 5 to 10% range. So people are buying more pixels. They're buying higher resolution displays, and they're able to drive 2 megapixels instead of 1.2 megapixels. So that in itself will drive the need for more graphics horsepower in the PC. In addition to the resolution, people are gaming on more monitors. So with the HD 5000 series, we introduced ATI Affinity technology, and we continue to drive the experience on 3 monitors, 5 monitors, or even 6 monitors. So that will triple or up to sextuple the amount of pixels that you will be driving from your graphics card. In addition to that, people are starting to game in stereo 3D modes. So that will double the horsepower that you need. So there's a lot of driving factors on the display side that mean the requirement for graphics horsepower is really moving forward at a quick pace. In addition to that, there's increasing demand for the power efficiency in graphics cards. So this means that at any given power budget for a 225 watt card, for a 300 watt card, for a 150 watt card, we need to be able to keep up with that pace of pixels and resolutions without falling behind in performance. So at any given power level, we're increasing our efficiency to keep up with that increase in graphics intensity and resolution. So just a check on the phone. Are you seeing the slide flip to slide 6? Or is it stuck on slide 5? Chris, would you be able to confirm if the slides are switching properly?
Yes, so now you're lead in innovation.
Oh, okay, sorry. I'm seeing 5 slides in a row here.
You're on slide 8.
Okay, I'm going to go back a little bit. Okay, so it should be point 4, increasing demand for power efficiency. As I mentioned, within a given power budget, we need to keep up with this demand for graphics horsepower and demand for resolution. So for every watt that we use, we need to deliver far more performance every year. Lastly, the 5th large driver in pushing for more graphics horsepower is a shift to compute. So we are seeing a lot more applications, such as compression, both on the video side and the file side. We're seeing a lot of everyday applications that even my parents or grandparents would use to edit photos or edit videos start to utilize the GPU, and that obviously requires the graphics card to keep pushing forward in performance so you can keep up with now high definition video or multiple panoramic images or these high compute intensive tasks that you're seeing become mainstream nowadays. So how do we keep up with this demand for graphics horsepower? Well, we do it through innovation. We do it through continually pushing the boundaries of what we can deliver technologically in our products. Part of that is always using the latest process technology. So we have been first to the new process technology for several generations now, going all the way back to 90 nanometer products. We have been first to 90, first to 80, first to 65, first to 55, first to 40, and with this product generation, we will be the first graphics manufacturer to use a 28 nanometer process. So what does that mean? It means that we can keep delivering on that performance per watt, performance per dollar, and absolute performance generation on generation. Another way we keep pushing forward is innovations like PCI Express. We have been first to many of these PCI Express and AGP interfaces, any system buses, and carrying on with that, we will be launching the first PCI Express Gen 3 GPU. The interface itself just delivers twice the bandwidth, so when you're running these high intense applications such as video compression or image recognition, image processing, or the latest games on multiple screens with multiple cards, that PCI Express system bandwidth is really going to help you in a lot of these latest applications and use cases. The other way that we're continually pushing is through things like Microsoft and open standard graphics interfaces. So we will be the first graphics manufacturer to release a product that's compliant for DirectX 11.1. We have been the first with DirectX 11. We've been first with things like open SDKs and runtimes for OpenCL, and also open APIs such as OpenGL. So we continually push these standards and API support to deliver to developers the functionality and the flexibility they need to deliver great applications to end users. So with that, there's a lot of new technology packed into here, and I'd like to talk a little bit more about the product stack itself now. So the point of this call is to introduce everyone here to our Southern Islands family of GPUs. As I mentioned, Southern Island is something that we've been working on for a long time. It has a lot of technologies packed into it, and I think you guys are going to be quite excited by all the features that we have in here. Southern Islands itself is a 3 GPU stack. They're all based on 28 nanometer, and the first chip in that stack is known as Tahiti. Tahiti is our big enthusiast GPU. Tahiti itself packs over 2,000 stream processors. It has a 384-bit memory bus. Tahiti has enough graphics horsepower to turn through all of the latest games, such as Battlefield 3, Deus Ex, Skyrim, up to 40% faster than the competition. So we're taking a step function in terms of performance here, and we're offering far more graphics horsepower than any other GPU on the market. But not only does Tahiti perform, it performs efficiently with things like 28 nanometer process, as well as some of our other power management technologies. Tahiti is able to perform, but do so without also taking a step function in power, in price, in all of these other categories that you come to expect from an efficient graphics card. Pitcairn is our sweet spot GPU. It will be launching a little bit later, and it will be following the legacy of products like the 6800 series or the 4800 series. Very sweet spot products targeted at gamers that really want a performant PC and are balancing all the components in their system. Cape Verde is following on. This is our performance GPU, really following in the legacy of products like the RV 770 Pro, which is the 4850, or the 4700 series, the 5700 series, and 6700 series. So delivering that perfect balance of performance, price, and power. Now, in addition to these efficiencies that we're driving, these products will be filled with a whole bunch of new features. And this is, I think, really the exciting part of this generation. So what are those new features? Here's a summary of the 3 big ones that you'll see. Graphics Core Next. This is something that our CTO, Eric Demers, has stood up and talked about at our Fusion Developer Summit, and we've had a lot of good feedback on it. It's a radical departure from the architecture that we've been using for the past 5 years, and it's really a culmination of both our compute and graphics architecture. We weren't settling on just a graphics architecture, and we wanted to make something that was very well suited for compute and other applications as well. So Graphics Core Next is key for that. We're also overhauling our Affinity technology. So Affinity 2.0 is a whole umbrella of different display modes, audio modes, and display features. Lastly, app acceleration is really getting a lot of steam in the market. We see a lot of developers very excited about it. We're seeing hundreds and hundreds of applications supporting standards like OpenCL and Direct Compute, as well as some of our video technologies. And we're seeing a lot of steam pick up on this front. As I mentioned, these are technologies that would be used by anyone. For example, my parents or grandparents would even use some of these technologies when they're editing videos. So it's becoming very pervasive in the market. And with over 100 million DirectX GPUs from AMD alone, there's a huge install base that developers can help accelerate applications. So looking at a little bit more details on each of these pillars. Graphics Core Next is a combination of our revolutionary graphics architecture, our 28 nanometer process, PCI Express Gen 3, and our umbrella of power management technologies. Those include AMD PowerTune technology, which most of you should be familiar with from our HD 6900 series, as well as a new technology called Zero Core Power. AMD Affinity is a combination of some new audio features, new video and display modes such as 5x1 landscape, new features on the display side such as the ability to combine stereo 3D or HD 3D technologies with Affinity, and flexibility that comes in the sense of more resolution supported, more display modes supported, and features such as universal bezel compensation. Lastly, app acceleration is a combination of our video codec engine, which is a new hardware block that's used for compressing video. It's a mixture of UVD functions and all of our software partnerships that can accelerate these everyday applications and really make the overall computing experience a lot better. So you put all these things together, and what you will see is that the 7900 series and 7000 series of graphics products are the most advanced graphics products on the market, and the 7900 series is the most powerful of those. So we're not settling on performance, we're not settling on efficiency, we're not settling on features, we're pushing them all forward, and we're delivering a great product all over. So now I'm going to take a closer look at the 7970 itself. This is the product that we will be launching in January. So the 7970 is our flagship GPU. It will be a GPU that packs over 2,000 stream processors. So it exactly has 2,048 stream processors arranged in 32 compute units. The memory interface is a 384-bit memory bus. As I mentioned, this is a big enthusiast GPU. We are targeting this thing for gamers, and that 384-bit memory bus is evidence of that. Each board will come standard with 3 gigs of GDDR5 connected to that interface, and that memory and memory bandwidth really becomes important when you're running on multiple displays, when you're running at ultra-high resolutions, and when you're running in stereoscopic modes. So those are a lot of pixels to push, and that memory quantity and memory bandwidth really help there. The 7970 itself has a 6-pin connector and an 8-pin connector, so the board is over-designed for 300 watts. We've left a lot of headroom on these things. So what we're seeing is that the overclocks we can hit on this are great. I'll talk about that a little bit later. The display configuration on this board comes standard with a dual-link DVI-I connector, an HDMI, and 2 mini DPs. Through DisplayPort 1.2, we are able to multi-stream out of those DisplayPort hubs and get up to 6 displays supported per GPU. So the first question that you might ask is, where has that stacked DVI connector gone? And the answer to that is, really, you don't need it. The reason for that is because every one of these boards will be shipping with an HDMI to DVI adapter. If you recall on the HD6000 series, with the 2 DVIs and HDMI, you were able to use any 2 of those. With the HDMI to DVI adapter, you can still get the same display configuration on those 3 displays by either using 2 DVIs or a DVI plus HDMI. So really, removing that stacked DVI connector doesn't affect your display options at all. In addition to that, each board, each 7970, will ship with an active mini DisplayPort to DVI connector that will support single-link DVI resolutions. So out of the box, each board will support 3 DVI affinity without any extra accessories required, except the monitors, of course. In terms of the dual BIOS switch, this is a feature that we've introduced with the HD6900 series. Every 7900 series will also come with this, so you guys can feel free to switch to the unprotected BIOS and flash it to your heart's content. You don't have to worry about killing the board because there is always a safe BIOS to revert to. Another area that we've received a lot of feedback on was the acoustics and the fan sync performance of our previous products. So this is something that we focused on and we've made sure to roll a lot of improvements into. First of all, the fan itself. We've moved to a new fan design. What you will see when you see pictures of the card and you see the board yourself is that the new fan has larger, wider fins. Why did we do this? Well, we've tuned this fan for a much lower RPM. This fan is tuned for anywhere between 2,000 and 2,400 RPM, whereas the fans that we've used on the 68 and 6900 series were tuned for 2,800 RPM to 3,000 RPM. So this fan is able to push higher CFM at a lower RPM rate with better acoustics. One of the other things that's really helping us on the acoustic and thermal side is the removal of that stacked DVI connector. That second DVI connector, which blocked half of the venting space, not only caused the air to be blocked, but it also caused turbulence when we were ducting the air around it. By removing that stacked DVI connector, we were able to keep these GPUs 7 to 8 degrees cooler than what we were able to do with the stacked DVI connector. So that's really helping the temperature itself, but also the acoustics, because we're not turning air, we're not causing turbulence in that airflow. We're also using a great vapor chamber technology on every single one of these cards. We have a multi-step vapor chamber, and this is the 6th generation that we've used vapor chambers on. What this multi-step vapor chamber does, it allows us to cover more of the board and increase that thermal mass of the vapor chamber, extend it over more of the board because we can step above components and extend it further down the board. One other thing that we're doing new on this is we're using a 2nd generation phase-changing thermal interface material. We first tried this on the HD6990, and the material, essentially what it does is it goes on solid, On first boot up, when the GPU heats up for the first time, this melts, it fills in any cracks, and it becomes very thin. And on cool down, the interface solidifies. It's almost a cement between the GPU and the fan sink. This means that we can keep this GPU roughly 2 degrees cooler than what we were able to do with the first generation phase-changing TIM on the 6990. However, what I would warn you is when we do get boards to you guys, or when you do play around with your samples, if you ever remove the heatsink, you will never be able to recreate that original contact between the GPU and the fan sink. So if you're running performance, if you're running acoustic, if you're running thermal tests on it, do it prior to ever taking your card apart. Because once you take the board apart, you won't be able to get that original factory seal anymore. So I'm talking about efficiency a lot in this presentation, and efficiency comes from a few areas. One of those is our power management technologies. So AMD PowerTune is one of the areas that we could really help drive that efficiency under load. Now, I hope most of you are familiar with this technology from our HD 6900 series launch, but if some of you aren't, I'll just give a quick recap. PowerTune is a technology which puts the GPU in control of its own power. We've made these GPUs intelligent, and we've made them able to calculate in real time how much power they're consuming at the microsecond level. So every microsecond, this GPU can understand how much power it's drawing, and it can actually adjust its clocks and take advantage of any thermal headroom if it's running under the max power, or if you're running a case that might threaten it from a thermal load, such as Fermark or OCCT, the GPU is intelligent enough that it can protect itself and guarantee that it's not going to exceed power. So PowerTune puts the GPU in control, it makes it intelligent, and it lets it control its own power so that it doesn't leave performance on the table when an application isn't demanding that much of it, and it doesn't get into a dangerous situation if you're running an application like Fermark or OCCT. PowerTune makes sure that we deliver performance when you need it most. But efficiency is not just about performance under load. It's not about performance per watt in a gaming situation. It's also about not wasting power when you don't need to. So that's where the next technology comes in. I mentioned this a few slides earlier, and this is something that's brand new with the HD 7900 series. Zero core power is a technology that really is the last word in what we can do in idle. Zero core power is a technology that can completely shut off the GPU when no active display needs to be driven. We're calling this long idle. So let me just quickly explain what long idle is. Long idle is what happens to your PC when you turn it on and walk away. So you could be going to bed overnight, leaving your PC on. You could be making dinner in the kitchen. You could be going to the bathroom. You could be leaving your media center on while your TV is off. These are all situations that we consider to be long idle, essentially a computer that's not in active use, even at the desktop. What we do is we detect that in the driver, and when a long idle case is detected, we just shut that GPU off. So we're able to get the card down to a 3-watt state by turning off that GPU. Essentially all that's left is that the memories are refreshing themselves, and the PCI Express interface is still on, so that your system can still talk to the GPU and wake it back up. Apart from that, this GPU is totally off, and we're not wasting any power. But we didn't settle on long idle. We've also made a lot of improvements on the static screen power as well. Static screen power on this board is down to 15 watts. That's a 40% improvement over what we were able to achieve with the 6900 series, and we've done that through a few techniques. First, we're able to put this into an engine clock deep sleep. So when there is no active movement on the screen, i.e. your mouse is just static, this thing will drop down to a 27 megahertz idle clock. In addition to that, we are actively compressing the contents of the frame buffer to make sure that we're using the least memory bandwidth necessary. And we're putting the DRAMs into stutter mode, which means we can really run at a low clock and only get information when we need from them. If I look at the trend over the past few years, I've talked about this long idle technology, about zero core power being the ultimate step in long idle. So here's the trend over the past few years, going back to our 4800 series products. If you had a 4870 in your system and you were leaving it on overnight, that 4870 would consume 90 watts continuously for the entire night, even though there's absolutely no graphics workload on the screen. That was wasting a lot of power if you add that up over days and weeks. Moving forward, we made a lot of improvements with the 5800 series. We were able to get that down to roughly 27 watts at long idle. So roughly 1/3 of the power of the previous generation, but that's still 27 watts that you're using continuously overnight. We made some further improvements with our 6900 series, but being based on generally the same technology, it was in the same ballpark, in the 20 to 30 watt range. With the 7900 series, in that long idle case, we're able to shut this GPU completely off and bring it down to about a 3 watt board power. So that's really is the ultimate idle power technology. But the other really cool aspect of this technology is not when you're not using your computer, but when you are using your computer. And as I mentioned, zero core power is able to kick in when there is no active display that needs to be powered. So there's one other very cool situation that you can see that in, and that's in Crossfire. So when you're in Crossfire, that second card, that third card, that fourth card, they're not actively driving displays. And when you're at your Windows desktop, checking your email, watching YouTube, there's absolutely no reason why those need to be burning power at idle. So if you take two systems, one that does not have zero core power, and each car is idling at roughly 25 watts, if you have 4 GPUs in that system, you will be wasting 100 watts of power when you're just idle at your desktop. You'll have to check in your email, but you'll still have 100 watts of heat, you'll still have 4 fans, and you'll still have, 100 watts of power being pulled from the wall. With zero core power, we're able to not only get that first card into a 15 watt state, but we're able to take out the second, third, and fourth card, turn off the power to them, just shut them down, and also turn off the fans. So there will be no extra heat generated, there will be no extra power drawn, and there will be no extra noise generated from that second, third, or fourth card. That's a really cool enthusiast technology, and it means that we can deliver the maximum GPU performance in Crossfire situations without any of the drawbacks in terms of power, power, heat, or noise. The other really cool enthusiast part of this card is the overclocking. So the board itself, I mentioned, was built for 300 watts. It does not use that in everyday load. So there's a lot of headroom on this board. This thing is able to overclock quite well. The board itself is 925 megahertz. Sorry, the GPU itself is 925 megahertz at default. With that clock speed, it's able to soundly beat every other product on the market. But we've left a lot of headroom on this thing, and we're seeing a lot of the boards overclock past 1 gigahertz. We're seeing a good chunk of them overclock to 1.1 gigahertz, and we've seen some boards that are hitting 1.2 gigahertz. So there's a lot of headroom. I urge you guys to play around with this thing, push it as hard as you can when you get samples in hand. To the engine clock, the memory is also very overclockable. So since we do have a 384-bit bus running at 5.5 gigabit per second, that delivers 264 gigabytes per second of memory bandwidth. That's a monster amount of bandwidth, and it's able to churn through all the latest games at great frame rates. However, we're seeing these things be able to push up to 6.5 gigabit per second or higher. That's a full gigabit per second overclock in the memory as a baseline. So you put all these together, and the 7970 is the most powerful GPU on the market. It has some of the most advanced technologies on the market, and we're seeing a lot of pent-up demand for these cards. The enthusiast crowd out there is just waiting for something new. They're waiting for the next big thing in graphics technology, and with the Tahiti GPU and the HD7970, we're going to deliver that to them. But we don't just stop there. We make these products efficient through things like zero core power. We're taking the ultimate step in idle power technologies, and with things like PowerTune, we're able to make this product efficient and be able to use well every watt that you pull from the wall. Lastly, this is just the start. So the HD7970 is the first product in this family, and we have a whole product generation to come, including the other Tahiti GPUs, the Pitcairn-based GPUs, and the Cape Verde-based GPUs. So with that, I'm going to move away from the product details and give you a quick overview of some of the updates in the architecture that we've made. So for those of you that were able to see our CTO, Eric Demers, talk about this at the Fusion Developer Summit, Graphics Core Next is the title of this the name of this architecture. Graphics Core Next. To explain it, I'll give you a little bit of a history on the graphics architectures that we've had over the past years. Going back to the 1990s and early 2000s, GPUs were mostly fixed function machines. They were able to do fixed function lighting, fixed function shading, which was great for games of the day, but it didn't really offer that much flexibility. Moving into our 9700 Pro, our first DX9 GPU, the 8500, the first DX8 GPU, we introduced programmable shaders. These were very simple shaders. The pipelines were still generally architected the same way, but we put a little bit of programming flexibility into the pipeline. So developers were able to code their own water shaders, reflection shaders, heat shaders, and create some very cool effects, and it was the beginning of the first programmable era. This lasted until the X1800 series and X1900 series, when the flexibility really became quite robust in terms of what game developers were able to use these products for. It was also the introduction of the first people who were using the GPU for compute. Following on to that second generation, we introduced the 2900 XT. This was the first product to use a fully unified shader architecture that was compatible with DX10. These were arranged in VLIW5 and VLIW4 arrangements and unified all of our vertex and pixel shaders together to allow a lot of flexibility in not only the graphics workload but the compute workloads as well. It was still mostly a graphics architecture. It was still designed for DirectX 10, but the flexibility was really starting to expand, and developers were able to do a lot more with these architectures. Fast forwarding to today, this is the start of the fourth generation of graphics architectures, and Graphics Core Next is the first chip to bring that to market. Graphics Core Next is a perfect merging of both graphics and compute capabilities. This thing is built like a compute chip without sacrificing anything on the graphics side. So we've been working on this architecture for years, and we've made sure that it's the perfect balanced architecture for both these graphics and compute workloads. We've built this thing for efficiency, so not only does it push graphic workloads up to much higher efficiency levels than our third generation unified shader architectures, but also on compute, we're seeing orders of magnitude improvements on their compute capabilities. These things are also enabling our fusion system architecture, which is something that you may have heard our CTO also talk about. This is the ability to really unify both the CPU and the GPU together in memory spaces and let them work together on these compute functions. Lastly, this architecture is very scalable. So you'll see from the architecture diagram on the next slide that this has the ability to really scale up or down depending on what we want to do with it. So I'll go into the block diagram now. This will show you just the heart of our Tahiti GPU, which is the first product to use Graphics Core Next. The GPU itself has 32 compute units, which equals a total of 2,048 stream processors. We have dual geometry engines. This is something that we introduced with our Cayman GPU and means that we have a lot of geometry throughput through the whole engine. There are 8 render backends, which means there are 32 ROPs. They're arranged in clusters of 4, and 128 Z-stencil units throughout the back of the chip. One of the new big things we have on here is a 768 L2 read-write cache. This is something that we've never had on a GPU before, and one of the reasons it's great on this chip is because it really helps that compute aspect of Graphics Core Next. The Tahiti GPU has a 384-bit memory interface. As I mentioned, it's running at 5.5 gigabit per second, so we can deliver a huge amount of memory bandwidth. And that gets really important when you're running with large workloads and you have a lot of data in memory that you're doing compute functions on. Lastly, the chip itself has 4.3 billion transistors on a 28 nanometer process. So if you compare this to any of the 40 nanometer GPUs on the market, this is a lot more than anything else out there that end users can buy. So I talked about efficiency. I talked about how this read-write L2 cache, about how the new architecture is really driving up efficiency. And here are a few examples of some shader workloads that we've extracted and compared between our 6970 and 7970. The baseline for this is the 6970. And roughly the first 40% of these bars are just due to the fact that This chip has roughly 35 to 40% more compute power between the extra compute units and the extra clock speed. Everything above 1.4x on this chart is due to the efficiency of the architecture. So if you look at some of the things like AES encryption, this is something that you need a lot of data and a lot of compute power to sit in cache. It's delivering performance up to 4 or 5x compared to the Cayman architecture. You'll see this in graphics workloads as well. Anything above 1.4x, which we see regularly, is due to graphics workloads performing more efficiently on this architecture than we have been able to do on our third generation products. So I talked about efficiency in compute workloads, but in addition to that, we have a lot of efficiencies in graphics workloads as well. So this slide shows our tessellation performance improvements going from our previous generation to this one. If any of you recall the slide that we showed during the 6900 series launch, we were talking about the tessellation improvements over the 5800 series. And those improvements generally focused around the 6 to 9 factor tessellation levels. So we saw a spike around there. What we're able to do now is take a complete overhaul of this chip and make sure that we can do tessellation on chip, on die, in that L2 read-write cache. We can do it a lot more efficiently, and we've reduced a lot of bottlenecks within the chip. So this thing can tessellate up to 4x faster than the previous generation. You can see that evident in benchmarks like Unigine Heaven, where we're delivering over twice the performance that we did with the HD 6900 series. Obviously, there's a lot of other games that are implementing tessellation, and you can see similar games that are up above and beyond that 1.4x that's purely delivered by the compute power, such as Crysis 2. We're seeing massive gains in Crysis 2, partly because of the tessellation improvements that we've put in this chip. So this is another cool feature that we've introduced. We call it partially resident textures. Partially resident textures are a technology that allow us to really treat an ultra-large texture as if it were cached on GPU memory but stored on the hard drive. Now, the benefit of this is that we can have textures that are on the order of terabytes of information, uncompressed obviously, sitting in a compressed format on the hard drive, and instead of having to load the entire texture into graphics memory, we can just look at what the game engine is asking for, pull small bits of that information, put those into graphics memory, and pull them for rendering on the scene. You might have heard of similar technologies from id in their mega texturing technology. This is hardware acceleration for mega texturing. The real benefit for end users is that when game developers start to implement this, and we're making it available through an OpenGL extension, is that you will be able to see massive textures operating with less memory usage than traditional standard bitmaps. So you can deliver much higher image quality, much higher resolution textures, and variability in the resolution depending on whether that object is close to the camera or far away, tucked behind a fridge somewhere. So we can deliver much higher image quality on games that use this, and we're working with developers through this OpenGL extension to get our PRT hardware acceleration for things like mega texturing built right into games. We will also have a demo that we will be posting to the web around launch time that shows off PRT as well as some other indirect lighting technologies, and you can see for yourself the benefit that PRT delivers in terms of the texture quality. Speaking of texture quality, this is another piece of feedback that we've heard a lot from you guys, that our anisotropic filtering still had some room for improvement. I mean, our Cayman GPU was great. It delivered stunning quality compared to other products on the market. However, there were some tests that you guys found through some very high noise filters that you were able to pick out some small inconsistencies between reference rasterizers and our hardware AF. What you'll see with the HD 7900 series is that our hardware AF is indistinguishable from reference rasterizers. We have, in essence, perfect AF quality with this generation of product. So I urge you not to take my word for it. Go to some of these sites that host texture tests, download them, and look for yourself. You should see absolutely no difference between our reference AF texture quality and the ideal reference rasterizer. So there's a lot of cool stuff packed in this new architecture. but there's a lot more than the new graphics core next architecture with this product generation. As I mentioned, this is only the first of 3 pillars. The second of which is Eyefinity technology. We're giving an overhaul to that. So now I would like to pass this call over to Roger Caro, the Technical Marketing Manager for our display and Eyefinity technologies, to give the next portion of this presentation.
Thanks, Devin. Good afternoon, everyone. My name is Roger Caro, and as Devin mentioned, I'm the Technical Marketing Manager in charge of all display technologies for AMD products. Without further ado, let's move on to the next slide. There's a little bit of delay here.
There we go.
Okay. So AMD is recognized in the industry as leaders in display technologies. Today's agenda will focus on improvements in the following areas of technologies. First, multi-display. You can see that we have perpetual hardware and software. AMD's Eyefinity multi-display technologies. Industry standard. The Northern Islands were the first GPUs to support both DisplayPort 1.2 and HDMI 1.4a, which are really the display interfaces of the future. And in like manner, NI were the first GPUs to support both DisplayPort and HDMI for Stereo 3D, which were important in enabling the open Stereo 3D ecosystem. We continue this leadership with the Southern Islands family. Next slide. But before we talk about the new display features in Tahiti, let's briefly review what AMD brought to the market with our last generation HD 6000 series graphics cards. Again, this is the first GPU to support both DisplayPort 1.2, ultra-high bandwidth, and Devin mentioned multi-stream for multi-display through single connector. And to give you an update, some may have seen the press release on VESA.org and DisplayPort.org websites that talks about the HD 6000 as the first DP 1.2 certified source device in the world. So this is an achievement for us. This, of course, carries over to the new HD 7000 series, which has already achieved certification. Northern Islands also supported HDMI 1.4a for Stereo 3D, which supported the new breed of stereoscopic 3D displays in the market. As mentioned before, HD 6000 was the first GPU to support Stereo 3D in both DP and HDMI, and we also supported legacy 3D displays through DVI and VGA. These are an integral part of our open Stereo 3D strategy, where we work with both software and hardware vendors to enable a flexible and open ecosystem. And finally, the HD 6000 series sports a display controller engine with the most advanced color correction hardware for consumers. So what did we do with South Islands to improve upon these advanced features? Let's move on to the next slide. The 7900 is the first single GPU to drive 3 Stereo 3D displays, which brings to the market the next level of gaming immersion. This is really a unification of our AMD Eyefinity and HD 3D technologies, and it is a great way to enjoy the extra horsepower in the 7900 series. We support this with existing DisplayPort 3D monitors. Next slide. Devin also briefly mentioned DDMA, which is our new audio feature heavily tied to our Eyefinity multi-display technology, and it stands for Discrete Digital Multipoint Audio. Well, how does this work, and how can end users benefit from this great technology? Today, GPUs can only support one audio stream at a time. So even if a user connects multiple audio-capable displays, like a TV or a monitor with display capability, only one of those displays can receive audio at any given time. So in the picture you see there, all the audio from all those video streams will be muxed or combined into one audio stream and presented to the user through the speakers of the middle display only. Next slide. The 7900 series, however, is the first GPU that can simultaneously output multiple and independent audio streams. So in this scenario, audio from the video stream of the nice couple on the left can be heard only through the speakers of the leftmost display, whereas the audio from the family of 5 can only be heard through the speakers on the rightmost display, and so on. This is what we call positional audio, and the unique use cases that this enables will be presented next. So in the scenario depicted here, unfortunately you can't see the animation, but in the scenario depicted here, the user is first watching a video on his or her laptop screen, and the audio can be heard from the notebook speakers. Now the user decides to do a bit of work and moves the window of video player to an external display with audio, and the audio follows. Meanwhile, the system audio, for example, your mouse click, your Outlook notifications, etc., stays on the notebook speaker. We have provided developers with an SDK to implement this. Next slide. Another unique application is for multi-display video conferencing. Some of you may have seen the UVU demo. If not, the short description of the demo is that each person can be heard only through the speakers of the displays where they are shown. Advantages include positional audio. You know exactly who is saying what by their position. And also, you also get clear audio because now the audio streams are not muxed and presented through one speaker only. Each audio stream is presented through its own speaker. Although not depicted here, another use case is, and you can envision this, some of our end users already do this, where you have multiple displays in different rooms, each with their own independent video and now audio stream, all running from one PC. Now, I'll talk about the new software features. Next slide. Software features and an update on our HD 3D ecosystem. You can see that AMD never settles in terms of display features. We listen to our customers and continue to enhance our Affinity technologies. Since 2009, we've released multiple improvements, but let's focus on what's new since October. Next slide. In October, we released a driver, a Catalyst driver, that enables new grid configurations, namely 5x1 portrait and 5x1 landscape. We also introduced flexible bezel compensation, which can be used regardless of the size of the monitor or even the dot pitch of the monitor. And also we enabled 16K by 16K, which is really used to enable configurations that exceed the 8192 by 8192 wide or 8192 high resolutions. Some of these configurations include 5x1 landscape using 1080p monitors or even 2560 by 1600 monitors. Next slide. So this month and in the near future, we will release even more new features, display features, such as we briefly talked about, the AMD Affinity and AMD HD 3D technologies, so what we call Affinity 3D, where you can have multiple 3D displays driven by one card. We'll also enable custom resolutions. Today, you cannot choose the middle resolution, and we use an algorithm to determine that, but in the future, the end user will determine what the middle resolution will be. We also have preset manager improvements, which is basically improving the behavior when you plug and unplug displays today. And taskbar positioning. Before, you have to, when you enable SLS on a desktop, basically the taskbar is by default on the leftmost side. Now you can reposition that. Next slide. Our AMD HD 3D technology now supports many games, and the most important of all are native 3D games. This is a short list of the 3D games that are available today that support natively, meaning you don't need a third-party 2D to 3D conversion software like DDD to enjoy HD 3D. However, we continue to support DDD, and today nearly 600 titles are supported with the DDD's middleware. Next slide. In terms of HD 3D hardware ecosystem, there are now multiple 3D monitors in the market that work with our technology from Samsung as well as LG. Next slide. So what did we do in our hardware to improve our 3D technology? This is the 7900 series, I should say, is the first GPU to support the 3 GHz HDMI feature. What this really enables is a unique gaming experience. Before, or I should say today, 3D TVs only support up to 1080p 24 hertz per eye, which is not really optimal for gaming. It's great for Blu-ray 3D, but not for stereo 3D gaming. Now with a new breed of 3D TVs that are coming next year, combined with HD 7900 series, our end users can enjoy 1080p 60 hertz per eye or 120 hertz total, real frames. Next slide. Ultra-high resolution support. We can support today's 4K displays, which require multiple inputs. For example, there's an ISO monitor that we worked with that supported 2 DisplayPort inputs. We also showed a Sony projector that required 4 DVI inputs. We do support those today. However, what's more important is that next generation 4K displays will only require 1 input, whether it's DisplayPort 1.2 or HDMI 1.483 gigs. The 7900 series is the first GPU that's ready for current and next generation displays. So the summary. The summary is that AMD never settles. We continue to improve our display technologies, which we've grouped into what we call the AMD Eyefinity Technology 2.0. We've united AMD Eyefinity multi-display technology and AMD HD 3D, and soon AMD Crossfire technologies. We've introduced the first GPU to support positional audio with discrete digital multipoint audio. And the 7900 series is the first to support DisplayPort 1.2 as well as fast HDMI. There are many more improvements as well. Thank you.
So, thanks, Roger. Now we have another section, the third pillar that I mentioned earlier, that's going to be focusing on the whole ecosystem of app acceleration as well as some of the new hardware features that we have on the Southern Islands family of GPUs. For that, I'd like to welcome Ab Nassef, Technical Marketing Manager for Media Technologies, to present this section.
Thank you, Devin. Hello, everyone. In this section, basically I'll be talking about AMD app acceleration, which really the focus is around delivering a comprehensive user experience with AMD Radeon 7900 series. And this is not new. I've been working on that and delivering such experience for many years now with a PC best-in-class HD playback acceleration, both in terms of codec and also in terms of video quality in the market. We also have been working on delivering the acceleration of transcoding both on the decode and the encode side with compute, but I will talk also about new additions we will have with the 7900 series. So in terms of three elements or pillars that we deliver with the AMD Radeon 7900 series is really about dedicated hardware and for video acceleration, but also a enhanced compute hardware and software, and finally the whole ecosystem of applications, third-party applications that the end user, basically the vector that we would deliver to the end user all these benefits. So as I was mentioning before, we've been in the market since 2007 with hardware acceleration of video decode with AMD Unified Video Decoder, known now as UVD. Since the first generation, we've been continuously improving the support for format to have a very flexible playback, and with the AMD Radeon 7900 series, you can see with third generation UVD, we continue to have a very, very flexible and comprehensive support for video formats for decode. And so, talking about the novelty with AMD Radeon 7900 series is actually the video codec engine. In addition to the UVD, we have a new dedicated fixed function hardware block in the GPU that does video encoding of H.264 HD content up to 1080p 60 frames per second. But also we have two modes here, and I will talk further about them, which one is full fixed and the other one is hybrid mode where it uses both fixed function and compute. So in terms of quality features, we have a 420 YUV color sampling video input support, which is the standard for consumer video, and also optimizations for the quality when we for scene detection, scene changes detection, whether it's for gaming, when you basically to optimize the quality for any given bit rate, but also for videos when someone does video editing, for instance. And also we have a variable compression quality on the VCE. And the third element here I wanted to talk about is the interfacing features. The VCE has actually the capability to do the audio and video multiplexing, so that's actually important in different cases, whether it's video editing when you do the final muxin, but also in cases if an application in the future wants to potentially do things like wireless display where the audio and video have to be muxed and sent to a wireless display. That could be also possible with the VCE. So, as I was mentioning earlier, there are two modes with VCE for the encode. So this is a faster than real time, as I said, 1080p up to 60 frames per second, and actually depending on the bit rate, we might go even higher than 60 frames per second, but this is the guaranteed, for common 1080p HD content. It's low latency, very power efficient HD encode, especially for other in cases in future products where in a mobile, for instance, situation where power will be very, very important. In this case, as you can notice, everything is done on the VCE. All the stages of the encode, until now with AMD Radeon up to 6000 series, we were doing a mix of actually mainly a partial encode on compute, but this is dedicated hardware that does all the encode separately from the 3D engine, which means that it can be while the user doing any other task, this will not affect the encode will not affect the performance. Even if someone wants to encode a game, this is separate from the 3D engine. There will be some memory transaction that will have some impact, but from processing perspective, this is completely separate from the 3D engine. The second mode of VCE, so it's the hybrid mode. This actually very important for a card for a GPU like a 7900 series that has a lot of compute capabilities, and we want to leverage that. We want to give the application developers the ability to tap into all the stream processes there and use them for stages of the encode that can be parallel. Things like the prediction, the picture prediction, the motion estimation. These are things that actually are very parallel and can take advantage of the compute. But the entropy stage, which is the end in that gray block with a solid white around the box, the entropy encode is very serial, so it's not the best actually to run it on stream processors or parallel engines. So we take basically the best of both worlds. We leverage the compute for all the parallel stages, which actually can be accelerated and have a scalability with higher end GPUs. And in the end, the entropy serial stage is done on the VCE. And in terms of applications, so we seeded the API and SDK for different developers. I think the full list, a wider list of applications on AMD App Acceleration is available on the full presentation. But I just wanted to give you an example of a third-party developer, which is Arcsoft, who already received the SDK. And this is actually a pre-announcement of their application, Total Media Theater 5.2. A lot of new features both from a user experience as a new UI and alpha blended UI, but also optimizations for AMD Radeon graphics, both for multi-view codec and acceleration, and also a pre-announcement of support of VCE encode included in their next in this version of Total Media Theater and other applications for that matter. This will be coming around Q1 2012 for end users, but we're still working with other developers also to enable VCE. One of the reasons that it's taken a little bit of time is that basically there's no standard, unlike DXVA for decode, there's no standard API by Microsoft to push that. But we also had different paths that developers asked us to support, both a Microsoft Direct Show path, but also in this case, for instance, for Microsoft, they are working in an OpenCL framework, so we had to develop our own OpenCL API for encode. That's one of the reasons that we are seeding. We've seeded the SDK, and we expect more applications coming in the beginning of 2012. So that was on the VCE side, but actually the hardware innovations of the Radeon 7900 didn't stop only to video fixed function blocks. In fact, even the compute engine actually has hardware innovations with a new hardware instruction, which is the quad SAD. But before going into that, I'll just explain quickly for those of you who are not familiar with SAD. It's basically an instruction that will, as the animation shows, I don't know if you have the chance to see it, it's basically will try to find in the neighboring blocks which one are the closest to the block, the one on the left. So it basically will do literally a sum of absolute differences, and the one with the lowest number of the SAD, the lowest value is the closest match. This is a very, very important instruction, and it's really used very frequently in video processing, in general, image processing, whether to detect motion in scenes, and also can be used in things like gesture detection and recognition, depth extraction, computer vision. So these are really applications that end user will benefit from when you accelerate an instruction like that. So knowing that, and all the experience we had for many years on the video, we thought that this actually would be a cool instruction to add in the hardware. This can be done on the CPU, but the fact that we're doing it on the hardware will accelerate really the process. As you can see, up to 1.8 terapixel per second can be processed with SAD, the newest in the Radeon 7900 series. In terms of a real-life application of this instruction, the QSAD in the 7900 series, is actually the AMD Steady Video 2.0. So the first version was released with the AMD Fusion Llano part this summer. Steady Video, and basically it removes the camera shake from the video and stabilizes the image. And actually, one of the key elements of all of this processing is actually the motion estimation. Whether it's a rotation, what type of motion is in the picture and in the video. So there's a lot of usage of the use of the quad instruction in motion estimation. In fact, on a typical 1080 60 hertz video, you can have actually up to 513 billion calculations to be done to detect 32 pixel possible motions. So that gives you an idea about how the heavy is processing this. And with the AMD 7900 series, the new QSAT instruction actually can deliver up to 10x speed up over CPU motion estimation. So the benefit of that from an end user is that when we finish that motion estimation faster, that will allow the process to add more processing, which will deliver even better quality than previous generation. So that was in terms of hardware and the software we've been working on to deliver the 7900 series. This is a quick reminder of the software and hardware we deliver has no meaning if we don't have applications that the end user can take advantage of. There are a lot of things now that are actually GPU accelerated, like browsers and plugins, things around productivity, and we see that more developers are taking advantage of the graphics power of the GPU. But we have also specific applications that things like vReveal that take advantage of OpenCL on AMD's GPUs. So all of that, basically, we continue to work on an ecosystem that adds more and more applications. And one of the new applications I want to talk to you about today is actually WinZip. As all of you probably have used that software for archiving and compression of files. So WinZip, which is owned by Corel, is actually bringing a new innovation to the market today with WinZip version 16.5 that leverages the OpenCL acceleration for compression, and actually the performance really in the 10x. I think I have lost the table here, but in the full slide deck we have the full performance numbers. This will come very soon to the end user and actually takes advantage of the GPU to accelerate the process. So as I was saying, quick summary, with AMD Radeon 7900 series, once again, a very comprehensive user experience in different aspects, whether it's multimedia with video acceleration of playback, great video quality, and also enhanced productivity. All of that delivered with great dedicated fixed function hardware, also an enhanced compute hardware and software stack, and more important, a growing ecosystem of applications that end users can take advantage of with AMD Radeon 7900 series. Thank you.
So that concludes the presentation for today. I believe Chris, as she mentioned, will like to open this up for any Q&A that we might have in the next 15 minutes.
Absolutely. Joe, over to you.
We will now begin the question and answer session. If you wish to ask a question, please press star 1 on your telephone and wait for your name to be announced. If you wish to cancel your request, please press the hash key. Once again, if you wish to ask a question today, please press star 1 on your telephone keypad and wait for your name to be announced. To cancel your request, please press the hash key. Your first question comes from John Avesta-Boulas. Please ask your question.
Hello from Greece. I'm John Avestopoulos from Moses Rhine. I would like to ask a few questions, please. First of all, could you tell us the die size?
The die size is 365 square millimeters for the Tahiti GPU.
Okay, thank you very much. Something else about the texture units, TMUs. Did I see correctly there were 4 per CU?
Yes, there are 4 per CU for a total of 128 TMUs per Tahiti GPU. Okay,
and the tessellation units? They were actually in the front end?
Yes. So the tessellation units are in the geometry setup front end. I believe we have a tessellation unit per geometry engine. So we have 2 per GPU on the Tahiti product.
Okay. And one last question, please. Could you tell us the performance relation between LAU and the VEC4?
Sorry, can you repeat that question, please?
Yes, okay. The performance relation of between the new LAU and the VLI W4 from 69 series?
Sure. That one is very dependent on the workload. Obviously, if the workload is vectorized or not will play a large part in whether there's a performance difference in it. Any scalar workloads will be able to work far faster. In terms of percent, I can't give you a number off the top of my head, but as you saw from the AES example, we're looking at 4 to 5 times the efficiency of our VLI W4 architecture. However, the flip side of that is that if a workload is very optimized for either our VLI W4 or VLI W5 architectures, we actually arrange in each CU 4 banks of 16 ALUs. Since we do arrange it that way, we can natively dispatch VLI W4 instructions to our scalar architecture and have them executed quite efficiently. So there is no performance loss on any workloads that are optimized for VLI W architectures. However, there is a massive performance gain for workloads that are optimized for scalar instructions.
Okay, thank you very much.
Your next question comes from Michael Vorchik. Please ask your question.
Sorry, but I don't have one, actually. That must be a mistake.
Just a reminder, if you wish to ask a question, please press star 1 on your telephone keypad and wait for your name to be announced. To cancel your request, please press the hash key. Your first question comes from Hendrik Vains. Please ask your question.
Hello together. I'd like to know if you provide super sampling in DirectX 11.
I know that we are carrying on our super sampling support from the HD6000 series, and I'd have to get back to you on that. I believe it's supported in DirectX 9. I would have to check on DirectX 10 and DirectX 11 support for that. I can follow up with an answer.
All right. Thank you.
Once again, if you wish to ask a question, please press star 1 on your telephone. That's star 1. Your next question comes from Attila Papdi. Please ask your question.
Hello, what about C++ support and x86 virtual memory support?
I'm sorry, could you repeat that question, please?
So I saw that the GCN architecture supports C++ and x86 virtual memory.
Oh,
on FSO. Fusion Developer Summit.
Yes, so as Eric talked about, we have a lot of virtual memory technologies built into this. The GCN architecture and Tahiti GPU by proxy will support those virtual memory modes. However, the platform is required for those virtual memories to be supported. So at this time, it is still something that will be enabled at some point in the future. It is not available today.
Okay, thank you.
Your next question comes from Hendrik Vines. Please ask your question.
Yeah, hello again. I'd like to know, do you have the exact price points of these 7970 yet?
We will be finalizing on the price point and communicating them prior to the launch. However, we don't have them for you today.
Okay, and another question would be, do you have a percentage of gamers who use more than one monitor?
So in terms of an actual percent, that's a very tricky number to pull together, but what I can share with you is 2 data points. What we see is the first easiest one to track is the number of active mini DisplayPort to DVI adapters that are sold. That will capture a portion of the multi-monitor market, will not capture the people with native DisplayPort displays, but we do see that those are selling extremely well. On the first 2 active DisplayPort adapters that we have helped our partners bring to market, that was the dual-link adapter in early 2009 and the single-link adapter in late 2009. The initial batches were sold out very quickly, and they were very sizable production runs. We've continued to see strong demand for this adapter. The second data point that we can capture is when system integrators offer configuration options for a second and third display, we see that they have very strong demand for people that are buying high-end systems to pick up triple displays.
All right. Okay, thank you.
Your next question comes from Russell Bennett. Please ask your question.
Hi there. You've spoken a lot about efficiency in this presentation, but unless I missed it, I don't think you said what the power draw of the 7970 will be under a full workload.
So the board is capable of 300 watts. Under normal gaming workloads, what you'll see is a low to mid 200s. So I don't have an exact number to share with you today, but you will see something around mid 200s in worst case.
Perfect.
Very similar to our previous high-end product and the competition's product.
Thanks.
Your next question comes from Elias Sviligos. Please ask your question.
Well, hello from Greece. Actually, one of my questions has just been answered. I'll just go on with the rest of them. I do assume that you are planning for smaller models on the Tahiti GPU, which will come when?
So those will come at a later date, since we are not launching that product at the same time as the 7970. I don't have too many details for you today, but I can assure you it is coming at a later date.
Would that be before or after or at the same time as the smaller GPUs, if you can answer that?
I can't comment on that, sorry.
All right. How about the availability and the yields of the 28 nanometer production from, I assume it's TSMC, right?
Yes, we are productizing these GPUs through TSMC's 28 nanometer process. We've been working with them for a long time on this and have been running many test chips as well as code development of their process. What we see is that the process is very stable, very predictable, and yielding well. So expect to see volume on shelf in that January timeframe.
All right. And the last question is the new architecture still VLIW based?
The new architecture is able to do scalar operations, so each ALU is able to be dispatched its own instruction. However, each CU is arranged as a bank of 4 banks of 16 ALUs. So through our compiler, we can dispatch either unique scalar operations or lump them together in a VLIW4 instruction and have that execute across a bank of 4 of them. So it's a very flexible architecture that can both be used for any graphics workloads that are VLIW friendly or any compute workloads that might be scalar friendly.
All right, thank you.
Your next question comes from Jakob Hugosson. Please ask your question.
Hello, I'd like to know what kind of performance differences you're expecting from the new graphics card compared to the 6970.
So performance versus the 6970 will be significant. What we're seeing is that some of the applications are running 50, 60, even 100% faster than our 6970 GPU. We will have full performance details for you shortly. We will be providing both a full benchmark guide along with the press decks, but just as general guidance right now, as I can give you depending on the application, anywhere between 50, 60, or 100% improvement. I do have to caution everyone, though, that this card has a lot of horsepower, so to see that, you have to be running at high resolutions. I would not expect you to see it at a low resolution, such as a single monitor 16 by 10 or single monitor 19 by 12. You really have to run this thing at 25 by 16 or multi-monitor resolutions to allow it to stretch its legs.
Okay. Also, I would like to know about the smaller GPUs. Will they be GCM based or like near older architecture, the VLIW4?
All of the technologies I've talked about today apply to Tahiti, Pitcairn, and Cape Verde. Our entire 28 nanometer product stack is graphics core next based with these technologies.
Okay. Also, I would like to expand on the question about the 28 nanometer yield at TSMC. Comparing to 40 nanometers, how would you say that you're that better now than it was back then during the same time period in production?
The 28 nanometer yields are stable, they're predictable, and they're yielding quite well. So while I can't draw a direct comparison, I can say that we're in very good shape to be launching our 28 nanometer product stack.
Okay, thank you very much.
Your next question comes from Lyle Matitiu. Please ask your question.
Hello, I have a couple of questions. The first one is, how is the overclocking abilities of the new graphics cards going to affect the power consumption at idle or at 2D mode?
They will not affect the power consumption at idle. So when we overclock, at least through Catalyst Control Center, what happens is our high state gets altered. So you might bring that high state up from 925 megahertz engine and 5.5 gigabit per second up to 1.1 gigahertz engine and 6 gigabit per second. However, the low state will be unaltered. So your high state power and performance will increase. Your low state power will still be just as good.
And my second question is, are you giving any extra tools in the Catalyst Control Center to control these tweaks, these tunings, more than we have now?
In terms of overclocking?
In terms of overclocking and monitoring the graphics card.
So the overdrive tab will remain generally the same. We do have a power tune slider, which was introduced with the 6900 series, that lets you guys either move the power tune limits up 20% or down 20%. The controls remain generally the same as the 6900 series. However, there are some other settings in Catalyst Control Center that we're making available, one of which is customizable crossfire profiles and customizable application profiles. So those will be released in the Q1 timeframe. And what those are the ability for an end user to change the crossfire profile themselves if there is a new game that comes out and they want to mix around with different profiles. Additionally, the application profiles allow you to set independent game and 3D settings for an EXE detectable launched game. For example, if you are running a game such as Borderlands and you want Borderlands to always run at 16 by 12 with morphological anti-aliasing enabled, but you want Crysis to run with a different tessellation level and with anisotropic filtering cranked up, you can have Catalyst Control Center detect the application that's launching and enable those specific settings that you have chosen for that game.
All right,
so
thank you.
There's a lot of new 3D and gaming features in there. However, overdrive is generally the same.
So we're coming to the end of our time, Joe, so perhaps we can wrap up if there's one final question.
Hi, Kristen. Hi there. Before we do go to the final question, I'd like to address one of the gentleman's question about multi-display. I would like to say that we did have our own survey, and about 9,000 of our gamers answered these questions. And one of the questions was, do you have Eyefinity enabled on 3 or more panels? 25% answered yes, and about 43% of the people who answered no plan on enabling Eyefinity in the near future. So the answer is, and by the way, that doesn't include users who use our GPUs for productivity. That was for gaming. So the answer is we do see a rise in the number of people who use multi-display setups. You know, as a matter of fact, LCD monitors are easier to put in multi-display configurations as compared to other displays. So, and monitor pricing is decreasing. So we do see a rise in multi-display users.
And one of the things driving that, as Roger mentioned, is the price. A good comparison or a situation that I've seen a lot is a user that is comparing a 30-inch 2560 by 1600 resolution display that might cost them 1,000 euros or more, and they contrast that with the ability to purchase 3 24-inch style displays that are 1920 by 1080. They can do that for about 500 euros and still get 50% more desktop real estate in that single larger monitor.
And a lot more pixels.
Great, thank you.
So sorry for interrupting that final question, but we can take that now.
No, that sounds good. Joe, a final question, please.
Okay, your final question comes from John Avestabulas. Please ask your question.
Yes, hello again. I think there is an error with the raw numbers. The memory channels are 384-bit, and on the slide I believe it's on 27. You say it's 8 render backends with 32 color ops and 128 stencil ops. Should it be 48 and 192?
With this new architecture, we have introduced an associativity between the color backends and the memory channels. So we have a 2 to 3 associativity between the ROPs themselves and the memory channels themselves that allow us to keep that ratio of 8 backends, so 32 ROPs to 12 memory channels, while they can still communicate with all of the memory and all of the ROPs together.
All right, thank you very much.
It's a different communication crossbar between the ROPs and the memory channels.
That's fine, thank you.
Great. Thanks a lot, Devin. Thank you all for joining us. We really appreciate your time, as I say. We will ensure that the presentation is distributed via your local PR agencies, and obviously if you have any further questions, please feel free to get in touch with them. Devin, any final words on the Southern Islands launch?
I would just like to thank everyone for taking the 90 minutes this morning to dial into this conference, and I hope everyone's as excited as we are.
Great. Thank you, Joe. You can close out the call, please.
That does conclude our conference for today. Thank you for participating, and you may all now disconnect.